Ochoa. He is the Senior Security Consultant of Core Security Technologies. Mr. Hernan has been working for Core Security Technologies for the last 9 years and has written a full-blown antivirus software mostly used to detect and remove Latin American viruses in '98. He participated in the research, design, and development of a multi-operating system security suite for a bank supporting DOS, Novel, Win31, Win95, Win98, WinNT, and wrote device drivers, intermediate drivers, and programs to hook syscalls. He was also involved in the creation of the Core Impact product and wrote several modules for it, including modules to inject impact agents on process in runtime, fake SMB server to capture credentials, etc. And he's currently actively working as a security consultant, doing pen testing, reverse engineering, black box security auditing, web app pen testing, source code auditing, and many more. His presentation today, Pass the Hash Toolkit for Windows. Join me in welcoming Mr. Hernan Ochoa.
Okay, hello everyone. Thanks for coming. Well, like I said, like Amy said, my presentation is going to be the Pass the Hash Toolkit for Windows, and I'm going to be talking about what is the Pass the Hash technique. I'm going to do a brief description of what the technique is and the current implementations and limitations of these implementations. I'm also going to then move on to explaining what actually is the Pass the Hash Toolkit for Windows. I'm going to give you a brief history about how I actually wrote the tool. I'm going to give you a description of the tools and advantages that these tools have compared to current implementations. I'm going to also give you some technical details on how the tools were actually implemented. That these details will give you some insight on how actually to use the tools. And I'm also going to describe some post-exploitation techniques that you can perform using the tools included in the toolkit. So I'm going to start by describing what is the Pass the Hash technique. Well, as you all, I'm sure you all know, Windows do not actually store the clear text version of the password of the users. Instead, it's stored two types of hashes of the user's password. That is the LM hash and the NTLM hash. So the Pass the Hash technique is basically a technique that allows you to use those hashes to authenticate to a remote host instead of using the clear text password, saving you from having to actually brute force the hashes to obtain the clear text password. This is a technique that was developed in 1997 by Paul Ashton, that was a member, or is, I don't know, of the Samba team project. I'm sure you also know that the Samba team is actually a project where they implement an open source version of the SMB protocol, that is the protocol used by Windows boxes to provide file sharing services and other services such as remote execution of procedures and things like that. So this technique is based on how the NTLM channel response authentication mechanism works. You can see a basic diagram and an oversimplified diagram of how this authentication mechanism works. Basically, when a client wants to access some resource that is shared by a server, for example, a shared folder, what it does is, of course, has to authenticate first to the server. And it does doing that mechanics. It first connects to the server sends back a random challenge. The client then applies a function F, we don't care about that function right now, using the random challenge sent by the server and the NT and NTLM hashes of the user's password. Then the server, once he receives the result of applying that function, does the same thing locally, and if with the hashes that it has stored for that particular user that is trying to authenticate, and if the responses match, that means that the client has the proper credentials and access is granted. If the result does not match, of course, access is denied. So basically what Paul Ashton said, okay, the secret in this basic channel response mechanism are both hashes, not the clear text password. So if you have the hashes, you don't need the clear text password. How the hashes are used, well, it varies between versions of the NTLM authentication protocol, but it doesn't matter. The important thing to have in mind is that if you have the hashes of the user's password, that is equivalent to having the clear text password, right? So the important thing about this is that this technique is particularly useful because after exploiting a Windows machine, you actually, like I said, get the hashes of the password. So this saves you for actually having to brute force the password. You can just use the hashes to authenticate to a remote host without having to spend time brute forcing the clear text password. So how can you obtain these hashes from your Windows box? Well, after exploitation of a machine, you can run tools such as password dump that will actually give you the result that you can see in the slide. It will give you the username, and then that one is a number that identifies the user that we don't care about. And the following two byte strings are actually the LM and NTLM hashes. This is just an example. That's why the number is 0, 1, 0, 2, etc. So there's also some other ways of obtaining these hashes. For example, by dumping the SAM database, that is where the Windows actually stores the hashes of the password. You can also sniff the traffic over the network and get the encrypted challenges that I mentioned when I explained the challenge response mechanism. But you actually have to brute force those encrypted credentials to get the hashes that you will be able to use in performing the pass-the-hash technique. You can also do cache dump and several other tools. The important thing is that after exploiting a machine, there are several ways that you can use to obtain the hashes, and then you can use those hashes to authenticate to a remote server without knowing the clear text password. So the original exploit code that was developed by Paul Ashton consisted in basically modifying a Samba client. The SMB client is the tool that is part of the Samba project, that is used to actually mount a share that is shared by a remote Windows box. So if you normally use SMB client, what you would do is you just specify, as you would expect, the username and the password, right? This is equivalent as using the netuse command in Windows boxes. So what Paul Ashton did is he basically modified the SMB client so you can provide to the tool the hashes of the password instead of the clear text password. And by doing that, he basically allows you to use these hashes without having to spend time brute forcing the clear text password. So since Paul Ashton published his exploit code, they're having a lot of other implementations of the same technique. For example, there's also a project that is casting of the Samba project that is called Samba TNG that also provides this functionality built in without needing the code that Paul Ashton did. And also there's lots of implementation of the various protocols included in the SMB protocol, written in Python, Ruby, Java, practically on every language. And the technique is also implemented by different exploitation frameworks such as Metasploit, Core Impact, Impacket, and I guess Canvas too, but I've never used it, so don't call me that. I don't know if it has it. So what is the problem with the current implementations of this technique? The problem is that all the tools that actually allows you to perform this technique have limited functionality. That is, they provide you with some part of the protocol specification, but they do not allow you to do everything that you would be able to use to do if you were using a Windows box. Why is that? Because basically what the tools do is, and developers of the tools do to come up with these tools, is they reverse engineer the protocol and then they implement that functionality. That means that the tools are always running behind the current running behind the current newest implementation that is provided by Windows, because they actually have to take the time to reverse engineer the protocol and then implement it. So that's basically a problem, because in some situations when you're doing a pen test, you for example, want to use some proprietary DCOM components that provide you some kind of administration capabilities, but you won't be able to use them because you only can do the pass-the-hash technique using the tools that have this limited functionality. So basically, you can use any Windows tools to perform this pass-the-hash up until now. So what is the pass-the-hash toolkit for Windows? It's basically a set of tools that brings this technique, the pass-the-hash technique, to the Windows platform. It was published in 2007, and it's free and open source, and you can download it and play with it, and it's written in C. And currently, it works on Windows XP, Windows Server 2003, and Windows Vista. It also you can make it work in Windows 2000, but the current implementation does not work in that operating system. So a little bit history about development of this tool. I first actually developed this tool in the year 2000, and I think it's featured in Hacking the Box, in Hacking Exposed, the book, something, I don't know if in the first version of the book or the second, I don't remember. But back then I couldn't publish the code for that tool because it was actually sold by the company that I work for to another company that I cannot mention. Or maybe I can, but I'm not sure about that. so I'm not going to mention the company. But back then, what I did do was wrote a paper actually detailing everything that you would need to do the technique yourself. This paper is called Modifying Windows NT Logon Credentials, and you can download it right now and get a sense of what I did back then. In 2007, what I did is I wrote the tool completely from scratch again, and I added some new things that I think you will find useful. So basically, I don't know, this is the first version of the tool had a GUI, and because it was primarily used during presentation and things like that, but the idea was to make it visual so people will actually see it and it would be appealing for audiences. But at the same time, since it had a GUI, it was not very suitable to be used during pen tests. So what are the advantages of the toolkit? The main advantage over the current implementations is that it provides you with unlimited functionality. That means that since it runs on Windows, every single tool that runs on Windows and uses NTLM authentications, you can use. For example, if you want to use NetUse to authenticate to a remote server, you can use it. If you want to connect to a remote SQL server using the default administration program provided by Microsoft, you can use it. You can use anything you want because basically what the tool does, it allows you to use the whole Windows box as an SMB client. And also, since right now the current implementation does not have a GUI, you can also use it during pen tests without requiring to have actually access to the GUI of the remote machine, right? So also there are there's a couple of new tools in the toolkit that were not provided with the original version of the toolkit that allows you to steal credentials that are stored in memory. And if you use this wisely, I hope you will see that later on in the presentation, you will understand that you can use this to actually own a Windows domain more easily. Okay, so now I'm going to give you some technical details about how the toolkit and the different tools in the toolkit were implemented. I think that they will, like I said, it will give you a nice insight into how the tools actually work, and it will help you actually understand how to use the tools. So what is it that we want to achieve? We want to achieve equivalent functionality as the functionality provided, for example, by the patch done by Paul Ashton back in '97 or any other implementation. The functionality that it provides is that you can, instead of passing the password to tools that make use of the SMB protocol, you can pass to these tools the hashes of the password. The idea would be that, for example, if we make an analogy between SMB client and NetUse, the idea would be to be able to use NetUse supplying the hashes instead of the password. But we don't want to be restricted to just one tool. We want to implement it in such a way that it will automatically work for every single tool that runs on Windows. We also want to be able to do this without logging in and logging out, because if you are in a pen test and you are attacking some other machine from your machine, you want to be able to authenticate to several hosts on the network in runtime just by changing the NT and LM hashes that you send over the network, and you also want to do this without having to reboot the machine. And I'm mentioning this because there have been some previous things that you were able to do in the past that were not as flexible as this implementation. So basically, how do we go about actually implementing this on Windows? We have to take a look at how the Windows NT logon and authentication model works. There are basically three main components in the Windows NT logon and authentication model. These are the logon processes that are system components that basically monitor I/O devices for logon attempts. Then you have the LSA, that is basically the user mode process in Windows that is in charge of system security policy and user authentication. And then you have the authentication packages. The authentication packages are the components that actually perform the actual authentication. For example, there are authentication packages for NTLM, for Kerberos, and things like that. They are the ones that create the notion of LSA logon sessions, and they are the ones that associate credentials to those logon sessions. We're going to see exactly what that means. So this is basically I'm putting names on the abstractions that I've just mentioned. For example, taking a look at how the NTLM authentication system works on Windows. The logon process in this case would be the winlogon.exe file. That is basically the component that is running behind the Windows dialog box that asks you for the username and password. So this is a logon process that actually intercepts logons that are made interactively from the keyboard. Then you have the LSA process actually provides an LSA authentication API that is the one used by logon processes to communicate with authentication packages and also allows authentication packages to communicate with the logon processes. In this case, winlogon.exe. And the component that implements the NTLM authentication package in Windows is called, or is implemented in the DLL MS-V1-O. So basically what happens is that when you are presented, for example, with, like I said, with the dialog box for Windows to enter your username and password, winlogon takes that password, it then calls on the LSA logon user API that ends up calling some code inside the MS-V1-O DLL that will take care of doing the actual NTLM authentication against the remote server. So this component, the MS-V1-O, what it does, it connects to a remote server or gets the information from the local SAM database. If the information matches, that is the user password is the same as the password that is stored on the local machine or remote machine, it proceeds to use the LSA authentication API to create a logon session. It does this by calling the LSA add credential function provided by LSA, and these credentials that it adds to the logon session that it has just created are the username, the domain name, and the hashes of the password that the user entered. And from now on, if you are, after you are logged in your Windows box, if, for example, you want to manage a share in a remote server, and you, for example, use the NetUse tool to do that, the single sign-on mechanism of Windows, what it will do, it will find your current logon session, find the associated credentials of that logon session, and will send that information, will use that information to perform the NTLM challenge response mechanism to authenticate to the remote server. So these notions are key to understanding how the toolkit was implemented, because you can see that logon sessions are associated with credentials, and these credentials are actually the ones that in memory contain the LM and NTLM hashes that are used to authenticate to remote servers. So the MS-V1-O component actually, like I said, communicates with LSA using the LSA authentication API. Upon system startup, what the LSA does, it calls a function in every single authentication package and provides to these packages what is called an LSA dispatch table, that is basically a table full of function pointers that then authentication packages can use to create logon sessions and to associate credentials to those logon sessions. Basically, this is a structure that is passed to every authentication package, and as you can see, it contains different functions for creating logon sessions and adding and deleting credentials from a logon session. And I'm mentioning this because these are one of the things that we are going to mess with to actually implement the toolkit on Windows. So like I said, to implement the toolkit on Windows, what we do is we mess with this information, with the logon sessions and with the credentials. Why? Because if we can, in runtime, change the credentials associated with the current logon session or any current or any other logon session that is present on the system, then when any program that actually uses the Windows API to perform NTLM authentication, all those APIs will use those credentials associated with the logon sessions. So if we are able to change in memory, in runtime, those credentials, we're going to be able to implement just what we wanted. That is, being able to use every single tool on Windows to perform NTLM authentication using the hashes that we want. So basically, in order to do this, the first approach that I took was to actually reverse engineering how LSA was maintaining all this information in memory. And as you can see in this slide, what it does, it basically has a double linked list of logon sessions. And there are like two levels of indirections that you have to go through to get to the actual NTLM credentials associated with the logon sessions. The names in this slide are just names that I invented, of course, because this is the product of reverse engineering the LSA process, right? So basically, you can see that the session entry has the session entry is each logon session is represented by a session entry structure. Then there are pointers from that structure to another intermediate structure that has another pointer to another intermediate structure that finally ends up in the information that we care about. That is the NTLM crest block. That is basically a structure that contains your domain name, your username, and the NTLM and LM hash of the password that you used to actually log on to Windows. How these credentials are stored in memory is like this. They are actually encrypted. They are not in clear text. They are encrypted with a random key that is generated when the system starts, and these credentials are encrypted using either this in CBC mode or RC4. The encryption mechanism chosen is based on the size of the block that contains the credentials. Basically, because if you use this X in CBC mode, the block has to be a multiple of 8, so that's the only reason why they use two encryption algorithms, I think. I really don't know why they actually make this distinction. They could just have padded the credentials, I don't know. So what is this X? This X is a variation of this that basically is supposed to add strength to the encryption by having 2 extra keys that are applied to every block that is encrypted before encrypting that block and after. I've never seen credentials encrypted with RC4 actually on any of the Windows boxes that I've seen and on which I've used the tool. I don't know why it is there. And actually, the random key that is used to encrypt these credentials is lost. But it doesn't matter because what is left in memory is the schedule key, the IV, or the initialization vector, and the widening keys. The widening keys are the 2 keys that I just mentioned that are part of this X and are used to actually add strength to the encryption algorithm. Okay, this is basically some pseudocode that describes what the system does to come up with these keys. This is something that you can go back home and if you're interested, take a look at. But you can clearly see how the key is actually generated randomly and then is actually overwritten by a key that is the key that's going to be used if at some moment the system decides to use the RC4 encryption algorithm to encrypt credentials. And here, if you take a look, a deeper look at the code, you can see how the system actually overrides the RC4 key, overrides the DESX CBC key, the original key, with the RC4 key. So that basically means that the RC4 key is available on memory at all times. Anyways, it doesn't matter because, like I said, by having the schedule key and the winding keys and the initialization vector, you can decrypt credentials anyways. This is also another function that is used by LSA to actually perform the encryption. And if you take a look at the code, the pseudocode that I wrote, you can see how the code actually decides what encryption algorithm it is going to use, if RC4 or DES. So now I'm going to describe what are the tools that are included in the toolkit, and I'm going to give you some more details on how these tools were implemented. So basically, the tools that are included in the toolkit are these. You have the IAM and the IAM alt tools. That these are the tools that you would use to actually perform the pass the hash technique on Windows. Then you have the who's there and who's there alt that are also 2 other programs that will allow you to steal credentials from memory. Then you have a pass the hash IDC script that is basically an IDA Pro script that is used to obtain some addresses that are needed by the tools. And I'm going to talk about that a little bit more in a few moments. And then you have just a helper tool that is called a hash tool that is just used, it's there so you can, if you are doing some tests or anything like that, you can actually, it will provide you with an easy way to generate LM and NTLM hashes to use during your tests. Well, the hash utility is implemented by using 2 very interesting undocumented functions provided by Windows. These are the system function 06 function and the system function 07 function. This function, as you can see on the slide, are provided by the ADBAP32 DLL, and these are very good functions to know about because they provide you with an easy way to generate LM and NTLM hashes on Windows without having to actually have your own implementation or this or the proprietary algorithm that is used to come out with the LM hashes. Okay, so remember that I said that IAM was the tool that was actually used to do the path hash technique, and HIRBSecConf was the tool used to steal credentials from memory. There are actually two ways of implementing this. I first developed what I would call the hard way because it's more difficult, because it tries to mess directly with the information that Windows stores in memory, and then I implemented an easier version, and I'm going to talk about the differences between these two versions and why actually they exist. Like I said, the hard way of doing this is to actually mess up with the information that is stored in memory. And that basically is good because you don't have to actually execute any kind of code inside the LSA process. What if you're doing a pen test and if something goes wrong and you generate an exception because, I don't know, you read an invalid memory function, an invalid memory address in LSA, that will actually crash the whole system. That's why I began by trying to implement this in this way. So basically what it does, but actually I was not able to accomplish that with IAM, basically because I was lazy and I just wanted to release the tool, but it can be done because, as I have told you, the information that is needed to actually mess directly with the information stored in memory is there, so you can do it. So this tool basically needs to find some functions in the memory address space of LSA to be able to add the credentials. And it needs, like I said, to execute code inside LSASS. So it's not that safe right now, but I have never had any major problems with it anyways. And the good thing is that the HIRBSecConf tool, that is the one that is used to steal credentials, that is something that you want to be doing in the pen test more often than using remote machines to perform the path hash technique, actually works just by reading memory. So it can never, almost never, I would say never, crash the remote machine. So it's very safe to use, and that is a good thing. And basically, like in the previous case, it also tries to find some addresses in memory inside the LSA process, LSASS.exe process, in order to mess with the credentials stored in memory and give you back that information. Like I said, what it does, it goes through the double linked list maintained by LSA, gets to the hashes, decrypts the hashes, and just prints out the hashes. This is basically the implementation of the code inside the tool that tries to find those memory positions that I mentioned before that the tool needs to actually be able to get the hashes or change the hashes. And I'm showing them because when I show you the tool, you will see that sometimes, since it is difficult to actually find these functions because these are not functions exported by any DLL, the different tools have different ways of finding these functions in memory, in runtime, doing some kind of heuristics, very basic heuristics. And I have just added some new features to the tool so that you can, if the tool doesn't work for you in the version of Windows that you have, you actually have a solution to actually make it work yourself without sending me an email and telling me, oh, it doesn't work in my version, can you fix it? Now you can fix it yourself. Basically, what the tool does is it has a different group of addresses hard-coded for different versions, and then just go through all the addresses to all the groups to try to find the correct addresses. And this has to be done because, of course, since these are not exported functions, you have to find them heuristically in runtime. The location of these addresses change based on the DLL version where these functions are located, also change between service packs, also between Windows versions, and also between the language of Windows that you have. So you see why it's not that easy to actually come up with the positions of these addresses in memory. This way is the way that is implemented by IAM alt and HIRBSecConf alt. And basically what it does, instead of messing with all these locations in memory, what it does, it just uses functions that are exported by the MS-V1O DLL, that is the one that provides you, that is the authentication package used for NTLM authentication. The tools are not as safer as, for example, who's there, because every single time that you run the tools, they inject the DLL into the lsass.exe process and execute code in that context. And like I said, if something goes wrong, the whole system will crash. But the good thing about these tools is that since they don't have to find such all the addresses that I mentioned before in memory, they tend to work on most systems without any modification or without you actually having to do anything extra. And that's why these tools are included in the toolkit. And who's there alt, that's the same thing. It also calls functions in the MS-V1O component to get the credentials and show you the credentials that are stored in memory. So to summarize, we have the IAM and the IAM alt tools that allows you to perform the passing hash technique. You can replace the current logon sessions or create new logon sessions with new credentials, so you don't mess with the current logon sessions of your that were created as a result of you logging in, if you don't want to mess up with the system that much. There are two main implementations of the same technique. IAM alt is a more generic one that tends to work on most systems, and IAM tries to do it in a more safer way, but right now it's not there yet. Who's there and who's there alt are the two tools that allow you to steal or list the credentials that are stored in memory. There are also two different implementations of the same technique, and like I said, as in IAM and IAM alt, the who's there alt version is the one that tends to work on more systems, and who's there just with memory, and is the tool of my choice, and is the tool that I use during pen test, because I know that you won't ever crash the remote system, what is of course very important. So I'm going to show you how these tools actually work. So, for example, I have here a virtual machine and my actual machine. I'm going to log into this machine. I'm going to fire up Wireshark to see the network traffic. Let me get the IP of the actual machine. So here, I'm just normally logged into Windows, and what I'm going to try to do is to view what are the share folders that the other machine has. And I'm going to capture the network traffic, if we can make this work. Okay, give me a minute. Okay, I chose the wrong interface. Hold on. Oh. It was right. Okay, something is not working. Okay, let's do this. Okay, hold on, something is not working very good. Okay, I'm sorry. Okay, now it is working. Okay, basically what I did is I tried to list the shares or the folders that are shared by the actual computer. So what I did is I ran just a net view on the remote computer, and as you can see, I could not log on to the remote computer. Why is that? Basically, I'm trying to authenticate using a user that does not exist in the other machine. And we can see this in the network traffic. Change the size of this. Okay. So basically, the client machine tried to authenticate to the remote server using the test user, and the test WinXP Pro is the domain name. But and as you can see, the logon failed. So now what I'm going to do is I'm going to use the tool, the IAM tool, to change in runtime the credentials that are associated with a logon session in Windows. So I know that the password of a user in the remote machine is this. So I basically use the hash tool to generate the LM and NTLM hashes of the user password. And this is equivalent as running, for example, the password dump tool in a compromised machine after exploitation, right? So now I'm going to use those hashes to change the hashes that are associated with my current logon session. So I'm going to take the hashes, and I'm going to use the IAM tool to change those hashes. So here I am running the IAM tool. The base switch is just used to turn on the heuristics to find the correct addresses to actually do the changing of the credentials in memory. That weird string that is Seyama Kitano is my username on the server. The domain, it doesn't matter in this case. You can put whatever you want. And then you have the hashes. So I'm going to run the tool now. And as you can see, the tool, it's saying that it changed in memory the hashes of your current logon session. And now what I'm going to do is going to attempt to list the things that are exported by the remote server. And hopefully, now it will work. Because I have in memory the correct hashes of the user on the remote computer. It didn't. Great. Okay. Okay. This is the thing that you don't want to happen in the presentation. Let me try this one more time. I know why, because I was changing the credentials on the server instead of in the client. So I'm going to do the same thing in the client. Hold on a sec. I'm gonna restart this thing. Okay. And now you can see that after running IAM, now I basically just run again the netview command, and this time it worked because the tool changed the credentials in memory, and those were the credentials that were sent over the network. If you take a look at the network capture, you will see that this time, instead of sending over the network the credentials for the test user, it sent send the, as the domain name, my domain, and the username that I have in the server. And the response of the attempt to authenticate was successful in this case, because I was able to actually connect to the server and get back the list of shared folders. So this is basically how the tool works. So basically, if you get the hashes, from now on you don't need to crack or spend any time trying to get the clear text password, because you can just use this tool and use Windows and any program that runs on Windows using those hashes to authenticate to remote servers. Let's get back to this. Okay, so how can you actually use this to help you own a Windows domain? If you compromise a machine and then you get the hashes from that machine, what you are getting are only the hashes of that local machine. If that machine is in a Windows domain, that compromise is only good for that single machine and not for the whole domain. So you would like to actually do something better than that. You want to actually compromise a whole domain. So what you can do is, after you compromise one machine, of course this is a post-exploitation technique, what you do is you get to run the who's there tool or the who's there alt tool to actually capture the credentials that are in memory. And this, if you're lucky, what you will be able to get is that instead of just getting the hashes that are stored in the local user database, you can obtain hashes of logon sessions that were created by, for example, domain admins. That means that, yes, you get the username, the domain name, and the hashes that are equivalent to the password of domain admins. And why would that happen? Why will you find yourself with those credentials in memory? This is because, for example, when you use remote desktop to log into a remote machine, that creates a logon session on the remote server. Creating a logon session means that the machine, for example, an administrator is connecting to, if it's connecting to, for example, a backup server or anything like that, when he enters his credentials, the username and the password, his credentials are actually stored on the remote computer. So if you happen to own that backup server, you can then use the who's there tool and get from memory the credentials associated with logon sessions. And if the administrator at some point in time actually log into that machine, you will be able to get his credentials. So just by owning one machine using this tool, you may get lucky and be able to own the whole domain. That is something that you wouldn't be able to do normally. So it's a very good technique. I've been using it for years, and it works every single time, because logon sessions are not only created by interactive sessions that are the ones, for example, created by remote desktop. They are created, for example, by services, because services in Windows can be run as different users. They can be created by scheduled tasks and things like that. So when you own a machine, you don't only get the logon sessions for credentials that are created from that point on, but you can also get credentials that were created in the past, where it's even better. And why is that? Because Windows has several, I would say, vulnerabilities that cause that credentials associated with logon sessions actually remain in memory even after that logon session is closed or eliminated from the system. So there's basically a vulnerability or series of flaws in different components of Windows. And I'm going to try to demonstrate now one way in which you can actually reproduce this behavior. Okay, so like before, I have the virtual machine and the actual machine. The virtual machine would be the server in this case. Okay, so, I'm going to do this. I'm going to actually restart the machine because I'm thinking that otherwise I won't be able to reproduce the bug. So hold on for a second. I think this machine is quick enough, so you won't have to be waiting for a long time. So I don't know if you actually get the idea, if I'm very good at explaining this, but I can really tell you that this actually works, and it works very good. If in memory, and of course the credentials that are in memory are only the credentials of the Flogger user. So now I'm going to log off. I'm logging off of the session created by the Flogger user. And I'm going to log in to the server using any other user. And now, as you can see, even when I log off of the session created by the Flogger user, the credentials of that user are still there. So that is a problem, and that's one of the ways, one of the things that happens with these credentials are stored in memory, and that's why this technique is also very useful, because you are able to get credentials for domain administrators even when they have logged off from that system like years ago, or well, months or hours or whatever. Because basically, I haven't tested this thoroughly, but it stays for days, and it never disappears. And I can show you, for example, there are actually no processes running as that user. I can run Task Manager, and you can see that it's showing processes from all users, and there's no process running as the Flogger user. Let's scroll this down. All processes are running as other accounts. So it's not that there's some orphan process running off of that logon session with the credentials of the Flogger user. So there is a bug. How much time do I have? Okay, 7 minutes. Okay, the conclusions. So basically what the path hash toolkit brings to you is the possibility of performing the path hash technique on the Windows platform. And that means that you don't have any more limitations on the functionality that you can use with this technique. You can use any tool that you want, and you can also use this during the pen test on a remote machine. Just as I show you how to use the IAM tool locally, you can use it remotely using HIRBSecConf, for example, to create a console session with a remote server, and you can do that and then use that remote machine as a pivoting point to some other machines on the network. And this is something that you weren't able to do before this tool came along. And the other good part of the toolkit is that using the who's there and the who's there alt tools, you are actually able to steal credentials that are stored in memory, and you are not only able to get credentials of current logon sessions, you are also able to obtain credentials of past logon sessions, and even logon sessions that were actually eliminated because of bugs that are present on Windows, they remain there. So this is very good because, like I said, when you compromise one machine, you can actually, just by running the who's there tool, instantly compromise the whole domain. And that's it. So I hope you like it. If you have any questions, I'm willing to try to answer them. No questions? Okay, there's a question.
Does it work without LM hash? When storing LM hash is prohibited by policy.
Can you talk a little louder? I can't hear you. Can you talk a little louder?
Does it work without LM hash?
Without a what?
Without LM hash, only with anti-LM.
I can't get what you're saying. With all hashes? No.
No.
It only works with the direct hash of the password, right?
Thank you.
You're welcome. Any other question?
Does it require administrator access to run?
Yeah, it's a post-exploitation tool. But the good thing is that, like I said, even if it is a post-exploitation tool, since you can actually, because of the things that I said, you can actually move from owning one machine to gaining control of the whole domain, it is still useful.
But then that means you need to gain access on that one machine first.
It's very common. If you have a a network with like servers, a lot of servers, it's very common for administrators to actually log into machines during their daily work, right?
No, I
So-
mean if you only have guest access on one machine, can you
no,
use that?
No, you have to actually own the machine.
Oh,
you have to at
okay.
least own one machine on the local network, and then you can move from that machine to owning the domain. It's a
Okay.
post-exploitation technique that requires administration privileges at least in one box.
Okay, thank you.
Thank you. Any other question? No?
Now, Hernan, I could be wrong, but you actually have some demonstration which, due to time constraints, you're not able to demo here today. Am I correct?
Oh, that actually was the demonstration that I did of the credentials remaining in memory even after logging off.
Okay. All right.
That's it.
Okay. Well, excellent. That's great. If there's anything more as well, and if you need a place or a venue to actually run through with the audience, feel free to do so over at our foyer area, or our secretary will be made available. So if you'd like to further the discussions with Hernan, even not during this presentation slot, anytime today and tomorrow, you will be around during the conference, right?
Yes, that's right.
Any other questions before we close this presentation? No? Oh, yes.
Excuse me, does this technique works against Windows Server 208?
I'm sorry, can you repeat the question? I'm sorry.
Does this tools works against Windows Server 208?
208, no, I haven't tested it. But I'm sure you only have to do some minor modifications, basically to find the addresses in memory, but I'm pretty sure that everything stays the same in that version of Windows. I'm not sure. It's something to look at, but I don't think they had changed it that much. That's it.
No other questions? Okay, well, ladies and gentlemen, thank you very much, Hernan Ochoa.
Thank you very much for your time.